Good day to Engineer Marvin Bartolome and to everyone who are watching this video. Today the topic that we shall cover is hydrogen power plant. First, let us give a quick explanation or description regarding hydrogen power plant. A hydrogen power plant is a concept designed for a new widespread source of electricity. Essentially, it is a facility which uses hydrogen to produce electrical energy. The term hydrogen here refers to pure hydrogen, which does not create or form any compounds with other elements.
Let's now look at how hydrogen power plant works. Large tanks of liquid hydrogen will feed into thousands of hydrogen fuel cells. These fuel cells are solid structures containing an electrolyte fluid and two terminals, much like batteries. As you can see here, the primary component of a hydrogen power plant is the hydrogen fuel cell. And itong hydrogen fuel cell, nagwo-work siya much like a battery. Para mas maintindihan natin yung working principle of hydrogen power plant, kailangan muna natin alamin kung paano ba gumagana yung battery, leading to working principle of hydrogen fuel cells. Dito naman tayo ngayon sa battery parts and functions, consisting electrolyte, anode, and cathode. The first one is electrolyte, a chemical compound that conducts electricity by changing into ions when melted or dissolved into a solution. It can be a liquid or paste-like substance. Samples nito are ammonium chloride, zinc chloride, potassium hydroxide, lithium tin phosphorus sulfide, and sulfuric acid. The second one is anode, the negative or reducing electrode that releases electrons to the external circuit and oxidizes during the electrochemical reaction. Samples naman nito are zinc, metallic lithium, and lead. Now, the last one is cathode, the positive or oxidizing electrode that acquires electrons from the external circuit and is reduced during the electrochemical reaction. Samples are manganese dioxide, carbon, lead dioxide, and copper. So yung anode is yung negative side ng battery, while yung cathode is the positive side ng battery. Now let's proceed to the battery schematic diagram para mas maintindihan natin kung paano ba nag-interact yung electrolyte, anode, and cathode. Makikita nyo dito na yung anode and cathode is nakasubmerged sa electrolyte solution. And you can see here in the middle, merong harang na nakalagay. Ito yung tinatawag na semi-permeable barrier. Ang purpose nito is to prevent the excess of electron within the anode side to go directly to the cathode. So here's how the battery works. Dito sa side ng anode, the electrolyte and anode nagpo-form ng chemical reaction na nagpo-produce ng excess of electrons. Kaya yung side na to is magiging negative, and if there are too many excess of electrons, it will keep moving, transferring from one atom to another in random. At the same time, it will repel one another. Kaya ang magiging result, yung excess of electrons will try to look for a place where there are fewer electrons. Dito naman tayo ngayon sa may side ng cathode. Electrolyte and cathode forms a chemical reaction that produces a substance that readily accepts electron. Kaya nagiging positive yung side ng cathode. Ngayon, kapag pinag-connect mo yung dalawa na yan, the excess electron sa may anode, magta-travel papunta sa may cathode. And yung cycle na yun is magre-repeat hanggang sa ma-deplete na yung battery.
Let's proceed to a battery construction and parts. As we all know, there are a lot of types of batteries, such as lithium-ion battery, alkaline battery, and many more. There is a box type or rectangular type of a battery. And also there is a cylindrical type and a lot more. But here, we will focus on cylindrical type of battery. So we have positive and negative terminals, anode and cathode, separator, and also metal lead material. And then, next is how a battery works. By placing things on a battery, the electron flows in the direction of positive to negative, going to the things we put in it, and then go back to the source. Since it is a direct current power supply, the electron flows in a single direction, simply from a chemical, simply simply from a chemical reaction that works on a battery, it turns to electrical energy. And then now, let's proceed to a chemical reaction in zinc carbon battery. This is for chemical enthusiasts. So here are the components of dry cell battery of a, or of a zinc carbon. Gaya nga ng aking sinabi kanina, we have a lot of different kinds of battery or different kinds of battery types. Pero dito, ang ating focus ay ang zinc carbon battery. And for better understanding, let's watch a short video about this kind of battery, which is zinc carbon battery.
And under that, the porous separator, which behaves like the salt bridge. Next in is the ammonium chloride zinc chloride paste, which is the electrolyte. Then some manganese 4 oxide, and stuck into that is a carbon rod, carbon in the form of graphite, a non-metal conductor. So zinc turns to zinc 2 plus ions and 2 electrons, and so electrons are released at the zinc electrode. They go through the circuit to do work, maybe through a bulb, and then those electrons are taken up at the graphite, where the manganese 4 oxide reacts with ammonium ions and the electron to make MnOH and ammonia gas.
And next is, let us know how does a hydrogen fuel cell works. Before we dive deeper to its topic, let us understand a basic fuel cell. It is similar to an electric cell, which consists of an anode and a cathode. Each of them consists of a gas diffusion layer, which is called a catalyst, made up of platinum. Between them, they have we call PEM, or also called as proton exchange membrane, also called as polymer electrolyte membrane hydrogen. So it enters from the anode, form the hydrogen storage tank, and oxygen from the ambient air is taken in. The byproduct is water and heat, and also the unused H2 is recycled. Now, let us understand how it works. As we can see, a bulb is connected as a load. From the hydrogen inlet, the hydrogen is taken. This hydrogen enters to the anode and then crosses the gas diffusion layer. And at the catalyst, the hydrogen is split into two, which is protons and two electrons. So all the hydrogen which enters is stripped at the catalyst. These electrons flows through the external circuit and light light of the load or a bulb, and then they cross and move towards the cathode. At the cathode end, the hydrogen protons move and to cross PEM layer. From the oxygen inlet, the oxygen enters the cathode and also crosses the gas diffusion layer. Then it combines to hydrogen protons in the presence of electrons to form H2O or water, and then this water um, moves out as a byproduct in the form of water vapor due to heat. Also, the unused oxygen moves out, the unused hydrogen is taken out, and in this and by this H2 is now being recycled. Another byproduct is the heat, which is emitted during these reactions.
How a fuel cell vehicle work. So, makikita natin sa picture dito yung figure ng isang single cell. So, how they work? Fuel cell car are powered by compressed hydrogen gas that feeds into an onboard fuel cell stack that doesn't burn the gas, meaning doesn't burn the gas, and but instead transform the fuel's chemical energy into electrical energy. So, and this energy then powers the car electric motors. So that's how it works. And makikita mo sa picture, medyo yung hydrogen, anode, the PEM, the oxygen water, cathode, then electricity. The next slide, makikita dito yung hydrogen fuel cell work principle. So, ito medyo mahaba to. And papaliwanag ko lang to ng sarili ko. Yung hydrogen fuel cell ay a catalyst at the anode ay kung paano siya, papaliwanag ko kung paano nagwo-work. And in summary, a catalyst at the anode separate hydrogen molecules into protons and electrons, which take the different path to the cathode. The electron go through an external circuit creating a flow of electricity. And that's how single fuel works. Kumbaga, if-feed nyo yun, then lalabas yung water, oxygen, ito. Next slide, dito makikita natin yung cinematic ng hydrogen power plant. So, yung purpose na to, makikita nyo pala sa picture yan, ganyan kung how it works. And purpose na yan is yung tatransfer niya yung conventional power plant into hydrogen power plant, and para yung facility is able to leverage a cheap renewable energy from the grid and turning that into hydrogen for use when the gas turbine facility is being called upon. So, and also, yung hydrogen could be produced with renewable resources when renewable energy production is high, and could be stored to generate electricity when renewable resources are limited and electricity demand is high. Next slide, why explore it? So, bakit natin i-explore itong ganitong uri ng power plant? So, para sa akin is fuel cell is marami siyang several benefits over conventional combustion-based technology currently used in many power plants and passenger vehicles. And unlike ng fossil fuel, when hydrogen is burned, it generates only water as the byproduct. So meaning ngayon, there's no harm or greenhouse gas emission, and there are also no air pollutant that create smog and cause health problems at the point of operation. So for this reason, it is an attractive for the future. So less pollution in the air. So masisave din natin yung ozone layer. Hindi makakaiwas din sa mga lung cancer. Ganun.
Hydrogen power plant. Why it hasn't gone mainstream? There are few hydrogen power plant and these few are in its development. Madami pang dapat i-improve. At the same time, kakaunti lang yung napoproduce niyang energy. So, the overall operation of hydrogen power plant is not perfect yet. Madami pang dapat ayusin. Hydrogen production through methane is the one reason why hasn't gone mainstream. About 95% of hydrogen used today is produced by a process called steam reforming. Yung steam reforming is yung pagsiseparate ng hydrogen atoms from carbon atoms in methane. This process is expensive. It releases greenhouse gases, which contributes to global warming, thereby canceling out any benefits to the environment. And second reason is hydrogen production through water. The other production method is electrolysis, which separates hydrogen from water. The downside is that it's expensive. From hydrogen to reach its full potential as energy source, scientists need to figure out a way to produce it inexpensively from clean, renewable sources. The direct reason is it is expensive. Then the third one is the cost. The cost of fuel cell can be high, even the use of platinum as one of the largest component material. However, there is work underway to find non-platinum catalyst approaches. As we know, the platinum is more expensive than yung gold. Kasi yung catalyst kasi sa hydrogen is platinum. Pero gumagawa na yung scientists and engineers to replace platinum as the catalyst for hydrogen. Kasi 1,000 of hydrogen fuel cell are need. Kaya kada isa doon, ang catalyst ay platinum. Kaya sobrang magiging mahal. So, next slide. Another reason is hydrogen storage. Scientists are still struggling with the challenge of how to store hydrogen because it has such a low energy density. Hydrogen needs to be kept under strong compression to be a viable fuel source, necessitating strong tanks and heavy-duty fueling lines, as there is currently no mainstream system of storage and distribution for hydrogen fuel. This is a major practical disadvantage. There is no major manufacturer who are willing to mass produce this type of tank that are exclusive for hydrogen. And this company who starting to build hydrogen power plant are still on prototyping stage. And the last reason is the hydrogen leak. Hydrogen leakage can occur during many steps of its production and use. Science magazine report in June 2003 that hydrogen leakage from widespread use of hydrogen fuel will gobble up ozone faster than CFCs do. During the operation and extraction is possible once it's occurred. One major destruction that can be created is the depletion of ozone layer. As we know, ang nagdi-deplete ng ozone layer is chlorofluorocarbon or the CFC. Pero mas malala ang epekto ng hydrogen kaysa sa CFC. And that's all the reason why it hasn't gone stream.
So dumako naman tayo sa latest development ng hydropower. So ano nga bang mga latest development ito? So simulan natin. So ang unang development nito is yung Long Range Energy Generation Project. So touted as a first of its kind power plant in the United States, the Long Range Energy Generation Project, a 485 megawatt megawatts facility being equipped to run on a mix in of natural gas and carbon-free hydrogen, is nearing completion at the site of a former aluminum smelter on the banks of the Ohio River. So, etong project na to is near to completion naman na siya. So, dito sinasabi na etong Long Range Energy Generation Project is magpo-produce ng 485 megawatts na na nagra-run gamit yung natural gas and carbon-free hydrogen. So, the facility first will burn a blend in 5% hydrogen in a General Electric Co. H-class gas turbine. So, eto sinasabi dito na ang include daw dito na mag-aano daw, magba-burn ng 5% magba-burn sila ng fuel na merong 5% na hydrogen. Tapos, the plant is intended to transition to 100% green hydrogen over the next decade by relying increasingly on renewable energy to power electrolysis machines that split water into its hydrogen and oxygen elements. So, ang plantang to daw is ang plano niya, syempre gaya nga ng ano natin is, ang gusto nila is yung magkaroon tayo ng 100% ng planta nito, rather. Gusto nito na maging 100% green hydrogen na siya sa susunod na mga dekada. Kasi, syempre, ang goal kasi natin is yung magkaroon tayo ng green, ng suitable renewable energy para sa ano natin. Kasi nga, di ba, tulad nga ng is, yung mga gas is nakakasira ng ozone layer, nagkakaroon mga greenhouse gases. So, syempre, ito ang pinakagusto natin. Magkaroon tayo ng green hydrogen, lalo-lalo na dito sa plantang to, dahil ito nga yung plano nila. So, next naman is the Siemens Energy. So, construction begins on world's largest hydrogen power plant, part of unique base load solar project. Siemens Energy will operate the unique 170 million euros facility in a remote part of French Guiana, which will provide 10 megawatts of power during the day and 3 megawatts at night. So, ito namang Siemens Energy naman daw ito is ginawa siya dun sa world's largest green hydrogen, sa merong load solar project. Ito kasi is connected siya sa solar power plant. At yung hydrogen power plant na to is connected din siya sa solar power plant. So, Eto sinabi dito na etong ano na 'to, 'tong Siemens Energy is magpo-provide siya ng 10 megawatts power during day and 3 megawatts naman during night. So, next is Siemens Energy will operate also naulit lang siya. And ito naman po is, lastly, a unique baseload renewables projects that combine the world's largest hydrogen power plant with a 16 megawatts machine for electrolysis of water and 3 megawatt fuel cell, 55 megawatts of solar panels and 20 megawatts on over 38 megawatt per hour of batteries has begun construction in French Guiana. So, dito, sinasabi lang dito na, siyempre hindi pa naman kasi fully furnished itong Siemens Energy na 'to. So, dito ang ano lang nito, pinapakita dito base kay Collins 2021, na hindi pa siya fully fully nagbe-base sa hydrogen na power plant. So, nagbe-base ang kung makikita nyo dito, ang pinakamalaking ano niya, production is sa solar panels which is the 55 megawatts. So, gaya ng ano, gaya nung isa kong in-explain is magkakaroon surely mag-ano, ang goal din nito is magkaroon sila ng 100 megawatts na, 100 megawatts tuloy, ng 100% na green hydrogen na magsu-supply sa ano, sa mismong project na 'to. So, ayun lang. So so yun lang po and salamat po sa pakikinig.